This is Exponent Packet, page 2, number 15 we'll start. So if you take a look, we've got an x to the 5th divided by x to the 2nd power. And we're supposed to simplify. So if you look here, it says, simplify each expression below using exponent rules. Your final answer should not include any negative exponents. You must show work in order to receive credit. Well, this one doesn't require a lot of work because all you got to do is, if you think about it, x to the 5th means x times x times x times x, all over x squared. Now, as discussed in class, x divided by x is just a 1, okay, and this is also a 1. And if you imagine 1 times all this, the 1's basically disappear. You don't need those 1's. And it comes out to be x to the 3rd. Well, the shortcut version of that is that you just take the 5 and you subtract the 2 and you end up with x to the 3rd. And that is considered simplified. Number 16, okay, so if we apply the same logic here, when you're dividing the same bases, so you have c to the 4th divided by c to the 8th, the shortcut version is to say, okay, well, 4 minus 8, the exponent's top exponent minus the bottom exponent. Well, 4 minus 8, if you were to double check that in your calculator, 4 minus 8 is negative 4. So you got to the negative 4th power. Okay, so now you can never leave negative exponents, as it says up here. So remember what negative exponents do. They're going to reciprocate the original. So imagine this as being over 1. Then this is going to go down. It's going to reciprocate to the denominator. So that 1 is going to multiply with c to the positive 4th. And since there is nothing up here, invisibly there's a 1, so you can just go ahead and replace the empty spot with a 1. And now we have the answer is 1 over c to the 4th, and that is our answer. Now, why isn't it c to the 4th? Because actually, if you think about it, let's take a look here. At the top, we have c times c times c times c. If you look at the original, c to the 4th. And on the bottom, we have 1, 2, 3, 4, 5, 6, 7, 8. So c to the 8th. So if you cancel, that's a 1, 1, 1, 1. You have a 1 that's left up here, and you have c to the 4th on the bottom, and that's what this is. So it's a couple of different ways to look at it. If it helps you to expand it out, by all means, when you expand it out, you'll see what truly is left on top and what's left on bottom. Now, number 17 gets a little bit tricky because you're starting off with negative exponents. So if it helps you, okay, there's a couple of ways to do this. I'm going to do it 2 different ways. So one way to do it is to go ahead and flip or reciprocate the exponents. So the 5 here already stays, but the x to the negative 4th will go to the bottom, becoming an x to the positive 4th. X to the negative 9 goes to the top, becomes x to the positive 9. Now you have an x on top and x on bottom, so you're going to subtract the exponents. So you get 5 left over, and then x to the 9 minus 4 is 5x to the 5th, and that is your final answer. Now some students were like, well, what, can I just go ahead and subtract? That's fine. So you still have a 5 left on top, okay, and you have x. Now negative 4, okay, subtracting a negative 9 with the 1 here. So this becomes a double negative, becomes a positive. So negative 4 plus 9 is 5. And you have that all over 1. But anytime you have 1 on the bottom, it just becomes, like, think about it, 5 divided by 1 is just 5. So these are the same. Okay, so these are just 2 different ways to go over it, or to get the same answer. If you didn't quite get that, rewind to the beginning of number 17 and just pick one method that makes sense to you and go with that. These are just 2. This is one way, and this is the second way to get the same answer. Number 18 also has a couple of ways to do the answer, but probably the simplest way to think about it is take care of one floor at a time, or everything in the numerator, take care of that, and then we'll worry about the denominator. So if you notice here, we have x to the 3rd times x to the 4th. If you remember multiplying in your foldable, when you multiply the same bases, you add the exponents. So 3 plus 4 is 7. If you imagine this is x times x times x times x times x times x times x, that's a total of 7 x's. Okay, so then now we've got an x on top and bottom. We're dividing the same bases, which means we subtract the exponents. So 7 minus 2 is 5, and that's our final answer. Okay, we're going to go on to number 19. So in this one, number 19, we've got a fraction, which is division here, with an exponent on the outside, which means we're going to have to distribute. Now, the interesting thing about distributing, if you think about this, what this really means is that you have 6 over z to the fourth times another 6 over z to the fourth times another 6 over z to the fourth. Okay, that's what this third means. So basically, you're taking the 6 and you're going to multiply it by itself 3 times, and you're going to take the z to the fourth and multiply it by itself 3 times. But what that's actually doing is you're distributing the exponents. So 6 has an invisible exponent of 1. You take it and multiply by 1, but you also distribute that 3 to the bottom because the whole fraction is being multiplied by itself 3 times. So if we take a look at it, we've got the base is 6, and then when you distribute the 3 to the 1, it becomes 3 times 1 is 3, over z to the 3 times 4 is 12. So some answers allow you to keep it this way, or you need to actually find out what 6 to the third is. Please don't say 18, because this is actually 6 times 6 times 6, which is 216. You can double check that. Or you can use the exponent button or multiply it by itself 3 times, and it's 216. So either of these answers are acceptable. It depends, like sometimes multiple choice would have one of these here. Sometimes they keep it with the 6 raised to the third power. Some of them want to see if you know that it's 216 and not 18, for example. So if you pause here, you can use the same idea for number 19 and apply it to number 20, and you should be able to get the right answer. Okay, so I would suggest that you pause here and try 20 on your own, and then come back and check and see if you did it right. So if you're back, okay, that's because you've paused it, or we're just moving on. So we have this 4 on the outside here, which means you're going to multiply this by itself 4 times. So that's the same as just distributing it to the 3 and also to the 5. So on top, okay, this a to the third becomes a to the 12th because this 3 multiplies with a 4. And this b to the 5th becomes b to the 20th because 5 times 4 is 20. You can't simplify that any further, so that is your final answer. Now you might want to try 21 on your own. I would strongly suggest it, and then see if you can figure it out. So 3 has its own window, x to the 4th has its own window, and y to the 6th has its own window. We have this 5 on the outside, which means all of these are going to get multiplied by themselves 5 times. Well, how do we do that? All you got to do is distribute the 5 to the 1, then to the 4, and also to the 6 at the bottom. Okay, so on the top, we got 3, and then 1 times 5 is 5, 3 to the 5th power. Then we have an x, and then 4 times 5 is 20, and then y, 6 times 5 is 30. So this is acceptable as an answer, or let's see what 3 to the 5th is. So I'm going to grab a calculator. Okay, 3 to the 5th, which is 243. So another way to write this is 243 x to the 20th power all over y to the 30th power. And that's another way to write it. So either one of these should be acceptable, but it depends, like if on a multiple choice, what they do with the numerical expression there. All right, number 22. Again, be careful here. It's not that hard of a problem because you can see you're going to distribute this 3. So this 3 is going to multiply with the 4, but down here, make sure you include the 5. The 5 also is going to get multiplied by itself 3 times. So make sure that this 3 distributes to the 9, but it also distributes to the 1. I know that looks kind of like a mess, but I'll talk you through it. So on top, we have the base m, and its exponent 4 gets multiplied by 3, and that's 12. Okay, on the bottom, you have 5, and its exponent 1 multiplies with the 3, and that becomes a 3. And then the n has a multiple or an exponent of 9. It gets multiplied by 3, and it's 27. And there's nothing more you can simplify, so you can leave it like this, or the only other way to simplify is to take 5 to the third. So 5 to the third is 5 xy third, and that's 125. Okay? And then you can write n to the 27th power. So these are considered equal. And last but not least, number 23. So I see 3 is going to get multiplied by the, well, the exponent for 3 is going to get multiplied by the 4. So this 4 distributes to the 1 and to the 7, and it distributes to this 1 and this 12. Okay, so let's see what we have left. So 3, its exponent is 1, and it's going to multiply by the 4, so it's 4. Then you have a base of x with 7, but that 7 multiplies by 4, and that's 28. On the bottom, you have a base of 2 with exponent 1, and you multiply it with 4, and it's 4. And then you have a y, 12 times 4 is 48. Okay, so now what do we have? Well, this is considered, you can say that simplified, but let's, there's another way to see it simplified. 3 to the 4th power, make sure you don't say 12. 3 to the 4th power is 3 times 3 times 3 times 3, that's 81. So you have an 81, and I'll just rewrite x to the 28th. And then 2 to the 4th is 2 times 2 times 2 times 2, 16, or you can just do 2 to the 4th power is 16, y to the 48. And that's my final answer. In fact, I was double checking that 81 and 16 cannot be reduced, and they cannot. There is no greatest common factor between these two that divides them. And that's it for numbers 15 to 23.